So now in this video, we're gonna look at a rubber diode, basically. So diodes have a forward voltage. I think this is why it comes up with that name. Usually like 0.7 volts if it's a rectifier diode, and that builds up across the diode. Now we have the transistor right here, and we're gonna do kind of the same thing. We're gonna build up a voltage across it, but it is adjustable. So that would be the rubber part. It's not a fixed forward voltage for the most part. So in any case, we have the transistor. It's an NPN Bipolar Junction Transistor, a 2N3904. Flat side is to the right. So we got emitter at the bottom, base in the middle, collector on top. And we have the trim pot. So it's set. You can see at the collector, we're getting, basically the arrow is pointing straight up right there. We got 10 or 1000 ohm resistor right there. And just because I'm using 10 volts. And so it's going basically to the base and heading to ground, turning the transistor on fully. So the 1K resistor is mostly what is limiting the current. You can see we got about 9 milliamps of current out of 10, because we got 10 volts and a 1000 ohm resistor. Plus that's not as accurate as a multimeter, but we do have to get that current through the base to emitter there, and thus we're going to lose about 0.6 volts. But that will be built up across the transistor. It'll be kind of like a diode right there at 0.6 volts. But as I turn this down, you saw we were up to like 9 milliamps of current, which we're just wasting. That's just going right to ground. We're interested in the voltage at this point though, which we will get to. As I said before, it's about 0.6 volts. If I turn this all the way down now, that turns the transistor off. And so we got somewhere around about 10 volts to the right there, but we do have 10,000 ohms of resistance right here as well. So you know, that's probably going to keep it a little bit lower right there. Not going to be quite 10 volts. So in case, 1000 ohm resistor, and almost no current is flowing right now. As I said, we got like 10,000 ohms of resistance, and at 10 volts, you know, plus the 1000, but 10,000 ohms at 10 volts is like 0.1 milliamps, I believe. Less than 1 milliamp, 0.1 off to the side, which this doesn't show. So, in any case, as we saw, the current is almost non-existent there. It's as high as it's going to get right there because we don't have a load. This is just a signal voltage. You would send it like to an op amp or something, which is wired as a voltage follower. So you send that to an op amp plus input. It's wired as a voltage follower. It could power a load at that voltage as long as the op amp can do so. And then you know, you can get a lower voltage built up across here. This would actually be the lowest voltage. It's conducting the best it can, and it doesn't fall perfectly in the middle, but some middle ground region voltage. And then if we go all the way down, then we'll have the full like supply voltage, other than we had that leakage there. So it'll be a little bit lower. So I got my multimeter. I really like this one, but it's not available anymore. But in case we're going to set it to voltage, I don't have to move the red probe for anything but high current. Black probe always stays there. And so we have the other end of the probe right there, holding it onto stuff. First off, makes it so I don't have a free hand. I was trying to aim, looking through the camera, and was way off. And this way I keep both hands free, because I'm going to do the same thing to the other one where I want to take our voltage measurement. So this one goes to 0 volts, negative supply, and this is how many volts higher or lower it is. And again, I was looking through the camera, which looked like I was headed right to what I wanted to clip, but wasn't even close. So there we go. So the transistor is off fully, and so no current is flowing through the transistor. But remember, this has 10,000 ohms of resistance right there. So the current's going through there, and it's about 10 times as much resistance over here. So we're ending up with about 1/10 the voltage, you know, basic voltage divider stuff. And you know, practically no current flowing though. So that's one thing to keep in mind with this. And this is why you make these practice circuits too, so you get a feel for the electrical properties. So as I said before, we're not going to get 5 volts, I mean, if we go halfway right there. So current's going through that resistor, but most of it's going through the transistor. A little bit has to go to the resistor, then to the base of the transistor. But as more current goes, it conducts more, and thus there's less current available, and it can't conduct anymore. So it's going to reach a middle, a point where the current is distributed as it can be. If you ask for more transistor current, it lowers the resistor current, but there'd be less base current, and so the transistor won't conduct as well. So it levels off at some point. Hopefully that makes sense. So you just gotta kind of turn this until you get the voltage you want. I don't know if this would be a logarithmic thing. They have a point where you start off, things don't change very quick, but then they change quicker and quicker as you get towards the end, I believe is the best way to explain logarithmic. But any case, here we got 9 volts, our fullest. We turn this and it quickly goes down. If this is going too fast, there are multi-turn trim pots. So I think you got to turn this 30 times to go from one end all the way to the other. And there's no stop though, but we won't worry about that. But in any case, yeah, we'll go like 4.5 or whatever. And there you can see we are, wasting a fair amount of current. There's voltage regulators that probably are more efficient, and the voltage regulators can provide that as power. This would just be kind of something if we want to give a voltage to like an op amp or something and let it provide power for whatever reason. So now let's go down. I don't know how much this changes based on supply voltage. Of course it will. You go to extremes, it will. But we got 10. Let's see what happens if I go down to 5. And sorry, it's trash day. But yeah, even as I lower the supply voltage, it's changing a little bit, but holding pretty steady. So now I saw basically this circuit fragment here, the rubber diode, in the book The Art of Electronics, where I also got the name rubber diode. Maybe it has like other names and stuff, I don't know. They didn't show this exact circuit, but I saw the I think they had 2 resistors actually to the transistor instead of a trim pot. But same thing. Fixed resistors, you wouldn't be able to adjust it after you set it. You'd have to keep adjusting resistors to get a different value. But this is adjustable. So, in any case, that's where I got it. I thought it was really cool. I don't know that I've found any circuits where I thought, hey, this is the best option, and I used it. I haven't got to that point yet, but at some point I will. This popped in my head earlier when I was trying to get a fixed voltage across, what was it? Oh yeah, so this is a trim pot. Like I wanted a fixed voltage across this as well. And, so over here, there'd be like a trim pot. So I don't know if that would draw too much current or not. Remember, we need to balance how much current's going through the base and the transistor. It does that automatically if you suck current away from it. That'll probably throw it off. That's why I say send it to an op amp. But that's kind of obnoxious, taking an op amp and using that to set a voltage across a trim pot. Probably better just to get a voltage regulator. And so I looked at one in the last video. Here we looked at the rubber diode. So not sure how much longer I'm going to drag on with voltage regulator stuff, because this is basically a voltage regulator. As we saw, as the supply voltage changed, it didn't change very much here. So, it regulated it, not as good as it could have, but, it did. So, in any case, rambled on long enough. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.